Wir schauen uns noch mal ein Video an zum Thema Coding Agent, speziell für lokale Agents. Und das ist ja genau das, was ich eben auch ganz viel gemacht habe und ausprobiert habe, wo ich viel investiert habe. Und ja, interessant, was die jetzt da so sagen werden. Also das ist hier dieser Kanal WebDevSimplified. Die machen ganz viel auch so Web-Development-Entwicklung. Videos und ja, es geht 40 Minuten lang, also es gibt da zwar auch schon andere, die ein bisschen kürzer sind, aber ja, vielleicht kann ich auch was lernen oder ihr auch und ich denke, wir starten direkt rein ins Video.
AI pricing is outrageous. Nearly all the monthly plans are completely gutted, which means you're stuck paying outrageous API pricing, which is why I decided to go down the rabbit hole of what it would look like to set up a local AI that runs entirely on my system, completely private, incredibly fast, and it's going to do everything, not just chat. It's going to have full autocomplete, so it's going to autocomplete anything that I want, and it has full agent mode where I can set up inside of VS Code my own agents I want to work with, and I can even use tools like the Pi command line tool or any other open code style agent to run with this. And in this video, I'm going to show you how to set all of this up. And I'm not just going to show you how to set it up by telling you what to do. I'm actually going to be explaining how every single concept works. So it doesn't matter when you watch this video, if you watch it right when it comes out or a year from now, I'm going to teach you the concepts you need to understand. So it doesn't matter what model you work with and what type of provider you work with, you can know how to set everything up perfectly for your exact situation and your exact hardware. And this will actually work no matter how powerful or weak your hardware is. I'm going to show you all the different things you can configure. This is essentially a local AI masterclass.
Oh, eins zurück. Cuban 3.6 35b A3b. Ich bin jetzt nur irgendwie curious, also mich interessiert es jetzt, was ich jetzt für eins verwende. Wird ja wohl nicht das gleiche sein jetzt, ne? Das ist Quatsch. Sekundchen. So. Okay, actually, ich benutze 30b A3b. Okay, nice. Und eher ein Coder. Na gut.
This is essentially a local AI masterclass. Welcome back to WebDevSimplified. My name's Kyle and my job is to simplify the web for you. And before we start diving into setting up our local AI models and finding which models we want to use, we first need to understand how these models actually run so we know how we can set them up most efficiently on our system. So a model is mostly composed of a few different things that we need to keep in mind for when we're setting it up. We have this model, and almost every model, if you look at them, is going to have some number of parameters. You can see this is 862 billion parameters, this is 1 billion parameters, and this has 128 billion parameters. So different models have more or less parameters, so that's one thing we care about.
Achtung, Billion, soweit ich weiß, Milliarden in Deutsch.
And another thing that we're going to be caring about for our models is going to be the context size. So we have parameters, and we have our context. And the context is just essentially how much information can you fit inside your model at one time. Newer and newer models tend to have larger and larger maximum context windows, which means they can hold more information in them, which means they forget things less frequently and are overall better at larger running tasks. So when you decide to get a model, you need to first find out how many parameters that model has and what type of context you want to put inside that model, because that'll determine how large the model is. For example, this model with 862 billion parameters, that is an absolutely massive model that you are not going to be able to run anywhere on your local hardware. It's just way, way too big. You need to have a much smaller model than that to run it on your hardware properly. Now, all of these models, they're going to be running on your GPU, your graphics card inside your computer. So let's just say that we have this box right here, and this box represents our GPU. And our GPU has lots of different statistics inside of it, like how fast it runs and so on. But the most important statistic for you to take account of is the VRAM. That is the video RAM, or the RAM that's inside your graphics card, is essentially how much memory your graphics card has dedicated to it. Now, if you're on a Mac computer, they have what's called unified memory on their newer models, and that means that they share the same memory between their graphics card and their processor and all the rest of the computer. So that means you can often get higher RAM numbers while at a cheaper price, while with a dedicated machine where you have a dedicated graphics card and dedicated RAM, you're generally going to have a smaller amount of VRAM to work with because it's dedicated just to the graphics card, but it'll often be slightly faster.
Diese MacBooks, ne, sollen viel besser sein dafür.
But for the most part, the most important thing is how much RAM you have, because when you take a model and you try to load that model on your computer, what it does is it takes this entire model, all the parameters and everything, and it tries to shove it directly into your graphics card on your computer inside of that RAM. So let's say that you have a GPU that has 16 gigabytes of RAM inside of it. That means that you can only fit a model that can fit within this 16 gigabytes of RAM, and that includes all the additional context and everything that model needs to run based on your code base or whatever else you're trying to do. Now, let's say, for example, that you have some model that you're loading and it actually is larger than 16 gigabytes. It goes past your GPU's limit. What happens is it'll fill your GPU as much as possible, so it'll fill that 16 gigabytes, and then it's going to go off to the rest of your computer where you have your normal default RAM, and it's going to fill in the overflow inside this section as well. So it's going to take all that extra overflow and put it directly inside your RAM here. And this is why we have really expensive graphics cards and RAM right now, because all the AI processes, they need graphics cards and they need RAM. So essentially it's being raised up in price because all the AI model producers are trying to get as much graphics cards and RAM as they can to support their models.
Ja, ich denke eher, die Fabriken konzentrieren sich derzeit auf diese Großbestellungen für spezielle Speichermodule, ne? Das ist jetzt nicht ganz normale RAM wie DRAM oder so für Desktop-Computer. Und deswegen geht natürlich der Preis von unserem normalen RAM auch hoch, weil die Kapazität dann nicht mehr da ist. Aber es ist nicht Grafikkarten und normalen RAM, dass die jetzt alle aufkaufen oder so.
Because the bigger models need bigger graphics card RAM and they need bigger computer RAM to be able to store all of that really complex information. So really the key takeaway is when you're trying to look at what model is going to work for you, you need to take into account how much RAM your graphics card has, as well as how much RAM your computer overall has. These are the two different things that you really need to focus on. And again, if you're on a system with unified RAM, like a Mac computer, that's going to be the same number. You're going to not have this computer RAM over here. Everything is going to be RAM that can be used for the graphics card. So it's most likely going to mean that you have more space on your graphics card, but it's shared between your computer. So once you hit the limit, there's no overflow. That's just the maximum you can do. Now, if you're on a Windows machine and you're unsure how much RAM you have inside your graphics card, you can just pull up the task manager, go to this performance section, and where it says dedicated GPU memory, you can see mine has 16 gigabytes of memory. I have a quite new graphics card that's a little bit higher end. Yours would say whatever number it is. And then you have your actual memory here. This is your system computer where all that overflow space is going to go. And I have some pretty high end specs because I use my computer for video editing, so it needs some higher end specs, but I'll show you how this will work on lower end specs as well.
Actually, ziemlich ähnlich zu meinem.
So now let's figure out how do we get this set up now that we understand kind of how this model works on our computer. The best and easiest way to get started at first, I recommend, is going to be LM-Studio because it has a really good user interface that makes it really easy to understand all these more complex things about RAM and so on. Everything is explained really well inside of here. So I would recommend downloading LM-Studio. And once you have that downloaded, a really good place to find models is going to be Hugging Face. But the nice thing about LM-Studio is they have their own model browser inside of it. Now, when you first download LM-Studio, it's probably going to look something like this on your screen, and you're not going to be able to do anything. When you try to click this up here to select a model, yours is going to be blank because you don't have any models at all loaded on your computer. So what you need to do is you need to go to this tab over here on the left, where it's the actual model tab right here. If you click on that, it's going to open up a search for you where you can search for all the different models that you possibly could want. Now, if you know what model is a good fit for you, you can just immediately search for it here. So for example, I know Qwen has relatively good coding related models. So I can search for Qwen and I can see kind of the most recent Qwen models that are available right now. And you can see it tells me what the model name is. And that 27B, that's how many parameters there are. This one's 35B for 35 billion, and this one's 9B for 9 billion. And if you look over here on the right-hand side, it actually tells me an estimate of how much space that's going to take up in my RAM of my actual graphics card. So you can see here, this Qwen 3.6 model with 27 billion parameters is estimated to take up about 17.48 gigabytes of RAM on.
Nee, was? Glaube ich nicht. Ich denke, das ist die Download-Size auf der Disk.
My computer. Now my graphics card doesn't have that much RAM, so it would have to overflow onto my normal system RAM. If you had more RAM than 17 whatever gigabytes, you could load the entire model. But if you take a look, we also have a 9 billion parameter version of a Qwen 3.5 model, and you can see that one is significantly smaller. It only takes 6.55 gigabytes, which means I can load the entire thing on my graphics card no problem. And
okay, also vielleicht ist es aber auch dasselbe. Also das, was das Model dann Space auf der Disk einnimmt, muss halt trotzdem dann auch komplett in die Grafikkarte rein. Aber das ist Minimum dann, was das einnimmt auf der Grafikkarte, weil es kommt dann auch Kontext dazu.
And generally, the smaller the model, the less good it's going to be at just general tasks that you give it, but the faster it's going to run because you can load the entire thing in your graphics card. Ideally, if you can load the entire model on your graphics card, it is going to be way, way, way faster. But later in this video, I'm going to show you how you can get around that with certain models that are available. Another thing that's really important to understand is you'll notice there's multiple types of this model with this like Q4, Q6, Q8, and so on. This stands for quantization. Essentially what that means is that they've taken the full large size of this model and they've essentially pared it down to be smaller by essentially rounding certain numbers that would normally be longer. They've rounded them to like whole numbers or smaller decimal place numbers, essentially shrinking the size of the model. That does slightly decrease the performance that you get out of the model, but the benefit is you can see the size drastically decreases. You can see from Q8 to Q4, that's essentially halving the size of the model. And a really good place to start is going to be models that are labeled as Q4. That's essentially 4 levels of quantization. 16 is like the base level. So 4, that's 16 divided by 4, that's essentially 4 levels of quantization from that base level 16 model. Now, another thing that's important when you're looking at models to try to download is to figure out what capabilities that model has. And these are going to be listed right here. If you're in LM Studio, you can see that this model has vision, tool use, and reasoning capability. Vision just means that it can process images. You can give it an image and it can read that image and look at it. Tool use just means that it can call tools properly inside of like agentic coding workflows. And reasoning means that the model is a thinking model. And this generally means that it'll spend time thinking and working through things. Generally, it'll be a little bit slower, but it'll generally give you better output. And if you're doing agentic coding, you definitely want to make sure that tool use is enabled in your model. And generally, you want to have reasoning as well, because it's going to give you much better output because it'll spend time thinking through what needs to be done, which is great for more complicated tasks. Unfortunately, these reasoning models generally tend to be larger, but that is okay because I can actually show you how you can get this to work a little quicker.
Also eigentlich ganz cool, ne? LM-Studio, keine Ahnung, ob man sich das wirklich installieren muss. Man kann die Models ja trotzdem anders hosten, aber diese Übersicht ist ganz cool. Aber es gibt sicherlich auch irgendwie eine Web-UI oder so, wo man sich das anschauen kann. Ja, gefällt mir.
So essentially, once you found a model you want inside of LM Studio, you can just click on that model and you can click download, and that's going to download that model in the background. And once you've done that, then you can go over to this third panel right here, which is where all of your different models are, and you can see all the models you have downloaded. Now, I have quite a few different models downloaded from various different testing purposes, but the ideal thing is to try to find a model that's going to be best suited for what you want to do inside your coding workflow, and then try to find one that's small enough to fit within what you're trying to do.
Steht ja auch nochmal Size on Disk, ne?
And if you don't see the models that you want inside this list right here, you can actually go to Hugging Face to find a much larger list of models.
So klar hat er ja vorher gezeigt. Hugging Face Seite kann man schauen.
So here I am on the Hugging Face site, and one really nice thing that you can do is you can sort by trending. That'll generally give you some of the more popular models at the top. And if you want to make sure it has reasoning, you can just toggle this inference available, and that'll only show you models that have that reasoning capability inside them. You can also fine tune like how many parameters the model has, so you can hopefully get one that fits within your graphics card. But from here, this can help you find some of the more popular models, or just Googling and asking like, hey, what are some popular models for coding agents that are open source and local? That'll give you really good ideas. Once you find a model that you want to work with, you're going to click on that model, and you can see over here where it says use this model. Click on that, and if you scroll down, you'll see this section at the very bottom that says browse quantizations. This is going to give you the smaller versions of those models, because these
Ah ja, okay. Hier, llama.cpp, llama oder LM-Studio. Also llama ist ja auch klar, so ein Model-Hoster, so ein Provider. Und llama.cpp, das ist ja der Server, den ich benutze.
These are way too large to work with locally. So when you click on that, it's then going to give you a massive list of all the quantizations. Now, Unsloth is really great at creating high-performing quantizations that are small, yet still quite powerful. So I generally recommend going with them, but really whichever one is going to be at the top here is probably the best bet if you're sorting by trending. So if we click on that, now if we scroll down, you can see there's a massive list over here that essentially tells you the exact size of this model and how much quantization is done. So you can see here 16-bit, that's just the raw as is, no changes made at all. That's the full model. 8-bit is essentially half the size of the full model because we've done like one level of quantization. And generally 4-bit is kind of a good happy sweet spot. That's essentially that 4 levels of quantization that I talked about, where it can shrink your model down drastically, but you can even sometimes get away with 3-bit or even 2-bit quantization for some of these larger models to make sure that they properly fit on your graphics card. Now,
Hier ist auch Hardware Compatibility, Login to add your hardware. Das ist cool eigentlich.
Let's say, for example, that I wanted to download this 3-bit model. I could just click on this model. And again, there's this use this model button. Scroll down and you can find, hopefully if you click view all, maybe here it is, LM Studio. Click on that and just say you want to open this in LM Studio. And essentially what that's going to do is open up your LM Studio and it's going to give you a link to download that exact model. So let's just try that out. We'll click on that open LM Studio. And you can see here immediately it's brought me to the page where I can click download and it'll download that model. So this is how you can fine tune exactly what models you get access to inside your system. So then once you have a list of all your different models that you want available on here, that means they're downloaded on your computer, but they're currently not loaded up and able to be used. So let's talk about how we can make that model usable. We can just go into this chat window here and you can see at the top it says select a model to load. And from here I can choose any model I want. Now I 100% recommend at the bottom here where it says manually choose model load parameters, toggle that on because that's going to allow you to fine tune exactly the parameters of your model that you're choosing to be able to use. So let's say that I wanted to use this model GPT-OSS 20 billion. This is a model that is quite large. It's got that 20 billion parameters. And as you can see here, it's around 11 gigabytes for the quantization that I have downloaded. And since I have 16 gigabytes of RAM in my graphics card, I should be able to fit this entire model on my graphics card. So when I click on this, you'll see I get a massive list of all these different options. This is what I talked about when I said that you wanted to have that enable advanced options. That's what gives you access to all these options. For the most part, I wouldn't worry about very many of them.
Cool, hier Estimated Memory Usage Beta. Das heißt, hier kann man cool die Parameter einstellen. Hier GPU, Offload, Cores, Thread Pool Size, Batch Size und Kontextgröße. Das ist natürlich das Krasseste. Cool, und dann updatet ihr hier dieses und dann kannst du immer schauen, ob es noch reinpasst in deinen VRAM.
Just make sure that this GPU offload, if you can fit the entire model on your graphics card, max this out to the very top. That just makes sure that the entire model loads on your graphics card and not on your CPU or system RAM. This is going to give you the most amount of speed possible.
Ich glaube, ich habe das GPU-Offload auf voll hochgeballert oder auf automatisch gelassen und dann, wenn mein großes Model läuft, ballert es die komplette Grafikkarte zu und natürlich auch RAM. Und dann kannst du nicht mehr so gut andere Sachen nebenher machen, wie Videos aufnehmen.
Next, you can modify your context lengths. And you'll notice as I increase this context length, this model up here for the total amount of space it takes up is going to increase, as you can see. Now, this isn't 100% accurate. If I max out this context length, it's probably going to take up more space than I have on my graphics card. So I'd recommend trying to set this in a good middle ground. Now, if you're just doing basic chat, you don't really need that big of a context, so we can just leave it down here somewhere at like maybe 5 or 10,000, and then I can click that I want to load this model. So just make sure that GPU offload is maxed out if you can fit it, and then set the context to somewhere that works for you. And you can play around with this however you need to make sure it fits within your computer. So
also voll cool, echt, da muss man nicht mehr so viel rumrecherchieren, das ist ja nice. Also das werde ich auf jeden Fall mir anschauen. Gut, das ist jetzt wieder dieses LM-Studio. Muss man das doch vielleicht irgendwie mal schauen oder... Gut, aber vielleicht gibt es das aber auch in diesem Hugging Face-Seite. Aber das ist auf jeden Fall cool, diese estimation.
When I click load model, that's going to load up the model. You can see that it's giving me that bar saying that the model is loading. And once it's finished loading, I can actually chat with this model. For example, I can come in here and say, hi, who are you? And now it's going to hopefully respond to me. Of course, it doesn't look like it's responding. That's because sometimes when you start a new chat, you need to choose what model you want for that chat. So let's choose that one that we've already loaded. And now I can click this, send it along, and you can see it's responding incredibly quickly, 124 tokens per second. And that's because this entire model fits directly inside my graphics card. If I actually pull this over and I show you the stats for this, you can see this dedicated GPU memory, it's nearly maxed out. I essentially have as much model as I can loaded into my graphics card, but there's nothing spilling out. You can see, like I said, it's pretty much maxed out, which is kind of where you want to be. You want to be generally towards the top, but not entirely maxed out. Otherwise, as your context fills up, it'll spill over into your system memory, and that's going to slow you down drastically. So with everything fitting in my graphics card, we have an incredibly quick model that's working and able to do whatever we want with it. And since this is a reasoning model with thinking capabilities, I can modify, for example, how much thinking I want the model to do for various responses. And you can see down here, I get my full how much of my context is being used. Now I want to show you what would happen if, for example, you load too much of a model that you can't actually fit on your entire graphics card. So let's come back here. We can click this eject button that essentially unloads that model. And if we take a look at my system memory, you can see it's dropped back down to a normal level because this isn't being loaded at all. And now let's go ahead. We're going to select that exact same model, but I'm going to max out the context as large as possible. This is most likely going to
Okay, jetzt stand da aber 13,9 irgendwas, also 14 Gig Estimation. Und er hat 16 GB RAM.
overflow how much space I have available.
Ja, okay, er zeigt immer nur Video auf hier. Also er benutzt ja schon. Sieht man nicht, ne? Dedicated GPU. Wie viel? Doch, da. 3 GB benutzt er ja schon. Okay, das wären dann 17 zu
So if we take a look at this chart, you'll see as it's loading, it's slowly increasing. And as it loads more, it's probably going to max me out. You can see here, I'm essentially maxed out. And my system memory, you can see, has made a huge spike because it's having to put a lot of additional information in that system memory. This is going to slow down the actual model. So if we say, give me some more information, this is probably going to be a much slower response. As you can see, it took longer to think, and you can see that the amount of tokens coming out are at a much, much slower rate. And if I finally let this finish, you're going to see that the tokens per second is probably going to be somewhere like 20 or 30 tokens per second instead of that 100 plus that we were getting on this one. So that's kind of the big difference between if you can fit it all in your graphics card or not. Ideally, you want to fit as much into your graphics card as you can because otherwise you're going to get rather slow responses. You can see
Ja, gut, bei ihm ist er trotzdem noch schnell.
This is still responding. I'll come back to you once it's done. So as you can see, we got here about 24 tokens per second as opposed to that 120 plus tokens per second. So a massive decrease in speed, about a 6 times decrease, just because a small amount of the model had to go over to my system memory as opposed to directly on my graphics card. Now this is a bit of a downside because it means we can only run smaller models, and smaller models are not nearly as smart as the large massive models that you get with like Claude or ChatGPT. But I'm going to show you a little bit of a trick that we can do to load these larger models while still having relatively good performance and offloading a lot of it to our system RAM in our computer. So what you want to do is you want to find a model that supports what's called MOE. MOE just stands for Mixture of Experts, and essentially it's kind of a fancy way of saying that you have a really big model, but only parts of that model are going to be working at a particular time, and other parts are maybe not going to be working at a time. So that means that you can kind of put the really hardworking stuff on your graphics card and the less hardworking stuff on your system RAM. That's kind of a very high level overview, not 100% accurate, but that's kind of how you can think about it. And most of the time with these models, if we take a look at our models, they're going to be labeled something along the lines of whatever the model name is with the parameters. Actually, it's probably going to be easier to see from here. So you can see this model right here, it says 35 billion parameters, and then it's got a second number, A3B. That means there are 3 billion active parameters. So you're going to see these naming conventions where it's like A plus another number, or it's going to be like 35X and then 25 or something.
Genau das. Ja.
So the first number is how big the model is, and the second number is going to be how many active parameters are. You can see some of the other models may have naming conventions like that, and this is very common, something you're going to see inside of that Hugging Face model. And a way that you're going to know if you have this mixture of element or of experts model is when you choose one of those types of models in LM Studio, you'll actually see some options at the very bottom. And this option called number of layers for which to force MOE weights onto the CPU. This essentially pushes those weights that are less important over to your normal computer, and it's going to keep the much more important stuff on your actual graphics card. For example, this model is quite large. You can see if I max out the context window of this, which I've done here, and if I try to keep the entire thing on my GPU by maxing out that GPU offload, you can see that this model is 26.63 gigabytes. That's the estimated amount of space it's going to take up. Now, this is not nearly 100% accurate, but you can see it's going to take up a lot of space on my GPU because this is a very large model. But what I've done, if I said that essentially I want to take 30 of those 40 layers that are these MOE layers, and I want to move them to the CPU. This means that I can use this model by keeping the really fast stuff loaded in my GPU while keeping the slower stuff loaded on the CPU. So if you're working with one of these MOE models, what you want to do, if possible, is max out this GPU offload as much as possible. Set your context wherever you want. I've maxed mine out because this is like my agentic coding workflow, so I want to have a larger context, but max out that GPU offload and then experiment with this number right here. See how low you can get it while still having good performance. Obviously, the lower the better because that means it's going to load all of it into your graphics card, but if your graphics card doesn't have enough space, slowly increase this until you find a good balance. And for me, that balance was about 3 to 4, so 30 out of 40 was exactly what I want. And when I click load on this model, and if we take a look as that model is loading, you can see that it's bumping up. And while it said it was going to take like 20 something gigabytes, you can see instead it's actually just pretty much touching the maximum amount of space that I have inside my graphics card. I may even have it pushed a little bit too far, but you can see it's essentially touching that maximum point inside my graphics card. And this is going to give you the best performance possible while using these larger models. So let's go ahead and actually try to create a chat with this. So we're just going to create a chat that says, hi, who are you? Click enter on that, and you can see it's not super fast. It's still quite a bit slower, but this is light years faster than what we would get if we were to run this model directly all on the graphics card without this MOE stuff. So you can see here we got about 43 tokens per second, which like I said isn't blazing fast, but it's still quite good. If we were to now take this exact same model, let's just eject it to unload it, and now we try to reload that particular model. And what I want to do is I want to come down here and we're just going to change this MOE, bring it all the way down to 0, essentially just running this and loading as much as possible into our graphics card. You'll probably immediately notice as this loads, my video is going to start lagging really bad because I'm maxing out my graphics card space as much as possible. You can see here it's touching the very tippy top, and it's just going to put more and more stuff in my system memory because it can't fit it all on my graphics card. And once this is loaded, we'll see that it is way slower than what we had before.
Ja, einfach genau dieselben Probleme hat wie ich da beim Video aufnehmen.
So it's still trying to load because there's so much stuff that it's having a hard time fitting it on my computer. And let's just get our message typed out. Give me a brief sentence of what this is about. Let's actually change that to paragraph. There we go. And now it just finished loading, and you can see it's going to be much slower. So it's processing the prompt, and you can see here, like, it is painfully slow. I mean, this is maybe like 1 token per second generously. So very slow. And that's the difference between the MOE. Essentially, we're taking the less important stuff, offloading it off the graphics card, and keeping the really important stuff on the graphics card. That's the entire thing behind that MOE section. Let's just stop this as this is taking forever, and I'm going to unload this so that my graphics card doesn't have to work so hard. So that
Also das ist halt irgendwie so unspezifisch, ne? The important stuff. Keep the important stuff on the GPU and the not so important stuff on the CPU. Ja, wer sagt denn, was important ist und was nicht important ist? Das ist irgendwie so schwammig, ne? Naja, wenn es funktioniert.
That's everything related to setting up essentially the chat portion of our models and loading the models on our computer, which is going to be really useful for when we want to set up autocomplete and agentic workflows. These MOE models are the best possible models for trying to get the most amount of power out of the least amount of hardware, and you don't need super powerful hardware to run all these models. The ones I've been showing you right now have been some of the larger models, but you can see like this model right here only takes up 1 gigabyte of space for your VRAM, and any graphics card, even incredibly old ones, are going to be able to run a model like this one. So if you have more limited hardware, you just have to scale down what particular models you choose. But if you have access to some of these MOE models at a high quantization, which again reduces the size while also slightly reducing the quality of the model, that means you can actually run some decently large models on even relatively lackluster hardware. Now,
die Frage ist halt immer, was ist besser? Also nimmt man jetzt so ein kleineres Cuban-Model und macht einfach eine bessere Quantization? Also, keine Ahnung, Q8 oder so, und passt trotzdem noch schön in den RAM rein und kann dann auch noch richtig gut den Kontext hochballern. Oder man nimmt halt so ein super starkes Model, das eben so hier dieses MOI hat und ja, macht dann da diesen Offload. Ja. Das ist halt interessant. Müsste man nämlich sich genau anschauen, was am Ende irgendwie besser performt. Ne? Aber ich schätze mal trotzdem die neueren und größeren Models.
Most often, you're probably not going to be interacting in a chat-based way. If you are, everything works pretty easily. But what you want to do is you want to set up autocomplete and you want to set up agentic coding. Those are the things that you care about the most. So to do that, if you see this little developer button right here, this is where we can actually load up models to use directly inside of other programs on our computer. And if you don't see this developer tab, that means that you needed to make sure when you installed LM Studio, you clicked like the show developer settings. So if you don't see this, just go down to your settings here and where it says developer, just make sure to toggle that developer mode on. So you should be able to see all these different developer settings. Now, this is where we can actually load multiple models onto our computer. Right now, there are no models being loaded, but if I wanted to load a model, I could just click load model here. I could choose one of those models like that 3.6 model that we were just looking at. Again, make sure everything is set up like I want it to be. And I can just, again, make sure it's all set up. I have this remember setting, so it's just saving exactly what I used for all my other times. I can click load model, and that's going to load that entire model directly onto my computer, but it's not being used for anything yet, but it is taking up space on my computer. And I can actually load multiple models if I want. I'm going to be loading a second model, which is this very small model right here, this 940 megabyte model. I'm going to be loading that one as well. Again, keeping all these default settings that I have, making sure that it's all on my GPU. So there we go. And give that a quick load button right there. So that's going to load up that full model as well. Now, if we take a look, that's essentially maxed out my entire GPU memory. And that's mostly because I'm also recording video. You may also see some stuttering in the video because I'm trying to record video and do all this AI stuff. So what I'm actually going to do is I'm going to take this Gwen model right here, this larger one, and I'm just going to scale back this context pretty heavily. So let's say that we want our context to be 71,000 instead. I can use that scroll bar on the side over here. And if I just hide my camera real quick so you can see the button below, I can just click this button called reload. That's going to reload my model with all these new configurations set inside of it. So now it's going to have a smaller context window, which should hopefully mean that it's going to be able to take up less space on my GPU, which means that my video hopefully won't be so laggy for you. Again, that's because I'm doing video editing or video recording at the same time I'm trying to do this. And generally you obviously wouldn't be doing that. So you would get even better results that I'm getting if you have the exact same or similar hardware. And again, just to show that working, if we come over here, you can see that again, the amount of GPU memory is much lower than it was before because of the fact that I reduced that context size. So the larger your context is, the more memory it takes up, and sometimes it can drastically increase the size of your model, sometimes even doubling what the size of your model is just by increasing that context too far. Now, the only last thing that we need to do is just make sure up here where it says status running, make sure that's checked. If this is unchecked, it means your server is not running. So just make sure your server is running so the other programs you want to interact with are able to actually reach this particular program. And you want to make sure you have this URL handy right here. This is the URL that this is going to connect to. And if we actually look down here, you can see we have all the different like OpenAI compatible endpoints, which means anything that works with OpenAI is going to work perfectly fine with LM-Studio. And everything I'm going to show you works perfectly with LM-Studio and these API endpoints right here. Now I'm going to show you how to set this up inside of VS Code for the autocomplete as well as the agentic mode. And then I'm also going to show you how to set this up in the terminal with Pi as well. And the nice thing is once you understand how all this connects, it doesn't matter what you decide to hook up. It's all going to work pretty much exactly the same way. It just might have slightly different configuration names, but all the important data is going to be the same. So continue is an extension inside of VS Code. Just make sure that you install this extension, and it's going to allow you to use AI agents inside of VS Code. And I'm also going to show you how to use the built-in GitHub Copilot portion of this to use your AI as well. But if you want autocomplete, continue is the only way to get that. There are other extensions that do the same, but I found that this one works quite well. Then what
Copilot autocomplete.
you want to do is you want to click on this section that says continue on your sidebar, and you can see here we now have access to all of our model stuff. Mine is already configured, but I'm going to show you how to configure it yourself. So you can see the settings icon right here. That's going to open up your settings section, and this is where you can toggle around and play around with some default settings. So you can scroll through all your different user settings for like font size and so on. For the most part, I don't want to mess around with this too much, but I'm going to show you that
Ich skippe jetzt ein bisschen, weil das ist nicht so interessant, denke ich mal. Außer da mit diesem komischen Continue-Ding da hat. Ja, klar, also hier ist halt einfach nur dann die Model-Referenz. Okay, was ist das? Ach so, Autocomplete, sagt er da. Schauen wir mal hier am häufigsten mehrfach wiederholt.
This file, and it's giving me everything that I want inside of it. So it is working and hooked up and able to modify and edit the code inside my project. Now I find that this continue section for doing the agentic coding is fine, but it seems to be a little bit buggier and not always work like I want it to. So instead I'm going to show you how to set up inside of GitHub Copilot as well. But to do that, you need to make sure you have the insider version of VS Code installed. Essentially, that's like the beta version. And then I can show you how to set it up in here because it's currently only available in the beta version. By the time this video comes out, it may be available on all the different versions, but right now it's only inside the beta version.
This is available.
So let's just expand this over. This is that chat window for Copilot. You don't even need a Copilot subscription to use this because what we can do is we can set up a local model. So this model dropdown right here, this is where you want to select that. And right here, there's going to be this gear icon. Click on that and it's going to open up a section where you can configure your models. You can see here's all the ones that are inside of Copilot that I have included with my subscription. But you can also see here are some that I set up. And to set these up, you click add models and choose OpenAI compatible. Then you can call this whatever you want. We're just going to call this LM-Studio.
Ja, das kennen wir alles schon. Also ich weiß nicht, aber Copilot, ob man es ohne Subscription den Agent Chat benutzen kann, weiß ich nicht, aber es gibt ja zumindest die Free. Und die Free ist wieder buchbar. War schon länger wieder buchbar, glaube ich. Also kann man sich das einfach umsonst holen und dann aufs Custom Model gehen.
Related stuff. So that's why I want to show you how you can set this up with something like Pi, or you could do like OpenCode or things like that with these agent harnesses. They're going to be much better for running your code in a terminal-based interface, which I think actually works really well for this type of coding. So to get started with Pi, you can just go to pi.dev, scroll down, and you're going to see a command that you can copy, and that's
okay, brauchen wir jetzt nicht sehen, wie das mit den unterschiedlichen Coding-Frameworks geht.
Just to give a little bit of a comparison here, this is actually a Sudoku app that I had it generate entirely vibe coded. And if we just pull over what the Sudoku app actually looks like.
Sehr interessant, der Sudoku-App. Was ist das hier mit Audio?
Me the exact same time for the actual output. Now, when I tested these models inside of a code base for doing bug fixes, that's when you notice the biggest time difference between them. Now, here's an example of the app that I had it fix a bug in. So this is a really simple video editor that I vibe coded for editing shorts a lot quicker because I just want to like cut out the beginning and ends of video clips. But you can see inside of this one, I essentially have the ability to kind of drag around where this is going to be cropped and so on. And I have the ability to play the audio that's the full audio. So it includes all the stuff that's cropped out or just the cropped out section. And there was a bug in my code where this very first scene, didn't matter what I toggled on this button, it would play the full audio clip from the beginning no matter what. I gave the exact same prompt to both the Claude Sonnet 4.6 model and the local Quen model, and I said to fix this bug. They both fixed it in exactly the same way. The code was literally identical between the two because it was a relatively small change that needed to be made, but it's a large code base. I mean, this is a full video editor. It's a rather large code base to do all this code, but it took a little bit longer in the Quen model than the Sonnet model. Sonnet model took about 45 seconds to fix the bug, while the Quen model took about 2.5 minutes. So a pretty significant difference in time, but that was because it spent a lot of time reading through all the code, and that's where the slower model is going to struggle more versus the larger model that can read through that much quicker. Now, again, it doesn't matter what type of hardware you're using, whether you're using incredibly fast hardware or you're using relatively older and slower hardware, you're going to be able to find a model that you can use on your own, and based on the different parameters and things that I talked about, you can fine tune that model to fit exactly in the parameters that you have for your hardware. Now, with how expensive these different cloud models are, it's going to be more and more important that you actually understand how to set up your own local models, which is what this video is about. So you don't need to constantly watch a new tutorial every month when a new model comes out. You know the skills to be able to set this up on your own. And if you're worried about the cost of actually getting into this, again, a lot of this with these smaller, lower end models will work on your lower end hardware. And if you already are subscribed to maybe a cloud plan for $100 or $200 a month, you could just cancel that plan for a couple months and have enough money to buy some really beefy hardware that's better than what I'm currently using, because my hardware is meant for video editing and not for AI. So you can buy AI focused hardware, which is much more powerful for much less money than what I paid for my hardware. Now, I really hope you enjoyed this AI focused video. If you want to see more AI videos from me, please let me know down in the comments what kind of AI topics you want me to cover, because I don't just want to be talking about like new models and things like that. I actually want to give you tutorials with real knowledge that are actually going to help you as a developer and not just hype up random different AI related things. So please let me know in the comments what kind of AI related stuff you'd want to see, or even non-AI related stuff. I just want to know what you would want to see from me. With that said, thank you very much for watching and have a good day.
Ja, nice. Also wirklich cool. Irgendwie, das war jetzt wirklich ein Unterschied zu dem vorigen. Cool, also schaut euch das gerne an. WebDevSimplified, also wie gesagt, er macht auch noch so andere, so Web-Development-Geschichten. Ja, folgt dem gerne mal. Und wie gesagt, ich fand es recht cool. Also er hat richtig gut erklärt. Ist auf alles eingegangen und klar, also diese Sache mit dem LM-Studio und dass man sich das so sizen kann und kalkulieren kann. Cool, schaue ich mir auf jeden Fall mal an. So. Gut, das war's dann. Bis zum nächsten Mal. Tschüss.